All right, here we are on example 7. Here we want to prove that n cubed plus 5n is divisible by 6 for all integers where n is bigger than or equal to 1. The first step is always going to be to sub in that first case. So n is an integer bigger than or equal to 1, so it's 1. So I can sub in 1 there and 1 there. 1 cubed is 1, 5 times 1 is 5. 5 plus 1 is 6. You can factor 6 out of that and have a whole number left over. So it is divisible by 6. Check. Step 2 is my assumption step. So here I'm again going to assume that my statement is true when I just change the n's to k's. But here I'm going to use the second strategy. It was the one I used up in example 4, where I'm going to write my own equation. I'm going to say that this has to be equal to 6 times some number, m. Again, m has to be any integer just like k is. Which tells me that k cubed plus 5k is divisible by 6, because you can factor 6 out of the result. All right, so in step 3, here's where I have to do my algebra to show that it's actually true. I'm going to take my original, substitute my k's with k plus 1s, and now I just have to argue until I have something that I know must be true. Right now, I've got two different things in parentheses. I would start by expanding that. K plus 1 cubed is going to be a trinomial. That's going to give us k cubed plus 3k squared plus 3k plus 1. The 5 will distribute into the parentheses there, give me 5k plus 5. All right, here now I'm going to do some skillful combining of terms. Remember, if I look up above, I have k cubed plus 5k. I know that was divisible by 6. So I can take this k cubed and that 5k there, put them off on the far left. That does have to be divisible by 6. I can replace that with 6 times some number. Also, this 5 plus the 1 there adds to be 6. That I can also move to the far left and say that will be divisible by 6 as well. So I just have to focus on the 3k squared plus the 3k that I have left over. Notice both of these have a 3 in them, and they also both have a k in them. So I can factor the 3 out and also a k out, which leaves me with a k plus 1 left over. Now, here's something that you may have to just be skillful to notice. K times k plus 1 has to be an even number. Can you justify that to yourselves? Well, k and k plus 1 are two consecutive numbers. It doesn't matter if they're 1 and 2, or 2 and 3, or 99 and 100. This one is one number bigger than that one. Okay, so they are consecutive, which means one of them is even and one of them is odd, right? It doesn't matter which one is the even one, the other one is the odd one. Okay, but an even times an odd has to be an even number, right? And isn't 3 times an even number divisible by 6? Hopefully you said yes, right? So I can take everything that I have here and I can factor 6 out, right? That 6 drops off, the m is left, this 6 factors out and I have a 1 left, and 3 times an even number is an even number divided by 2, which is still going to be a whole number. So that is divisible by 6, right? So this was originally true for all the places where n equaled k, and now I've showed that it's also true for all the times when n equals k plus 1. Therefore, by the principle of mathematical induction, n cubed plus 5n is divisible by 6 for all positive integers of n.